Okay, so this is going to be the last video. We're going to do a graph together, and then you guys will get to do a graph on your own. If you don't have paper in front of you, press pause. Please go get some paper, either graph paper or lined paper, and then come back when you have everything in front. So go get paper, pencil, all that stuff if you don't already have it in front of you, and then come back. Okay, so we're going to go ahead and say, let's see, it says Lana makes $15 an hour, and she already has $5. So from what we did last time, I recognize this as the slope right away, because 15 an hour, and the already has 5, that's going to go ahead and be my y-intercept. So let's go ahead and label that as the y-intercept. Okay, so Lana has 15 an hour and already has $5 in her bank account. Graph the relationship between her hours of work and the money in her account. So all that's letting you know is that if X is the hours of work and Y is the money in the account, it wants me to graph this relationship, or in other words, you're going to write the equation. So I'm going to have Y equals, I'm still following mx plus b. My m is my slope, which I just said was 15. 15x plus my y-intercept, which is 5. So this would be the equation there. How I can go on and graph it is anytime you want to graph, you want to go ahead and make yourself an XY table. So I'm going to go ahead and make myself a table of values here. I'm going to just kind of extend this. These are going to be my X values. These are my Y's. And I'm going to plug them into this equation here. This equation represents the situation. And I always do 0, 1, 2, and 3 if I can. I keep them simple. Sometimes you might skip ahead, like I might do 0, 1, 2, and then 10, kind of like doing a bigger number, like, okay, I know what happens when it goes 0, 1, 2, let's jump all the way to 3. Sometimes I'll even throw in a negative number here, like I'll put a -1, because I want to see what happens when negative numbers happen. But in this case, since X represents my hours, I cannot have a negative hour. So in this particular situation, I want to just stick with positive values. Okay, so what you do to find your y values given your x is I'm going to just start plugging in these values for x one by one into my equation. So my first one is y equals 15, but instead of x, I'm going to put my first x, which is 0. 15 times 0 plus 5. Then I can go ahead and multiply. 15 times 0 is just 0. 0 plus 5 will just be 5. Bringing down that y all the way down. So then I can go ahead and on this side, I'm going to go ahead and put 5. And then if you think about what this represents in your problem, remember X is hours, Y is money. So at 0 hours of work, Lana makes $5, which has to do with her problem up here of she already has 5. So at 0 hours of work, she already had $5. Okay, and then you could just keep this process going. So I'm going to go ahead and take my equation again, y equals 15. But instead of x, I'm putting my next x, which is 1. So I'm going to have 15 times 1. And if you're comfortable with just moving forward, you're more than welcome to skip to the end of this video. 15 times 1 is just 15. 15 plus 5 is going to be 20. So now I have a 20 over here on my table. Okay, and then that sentence would be after 1 hour of work, she has $20, which makes sense because she makes 15 an hour and she already had 5. Then you just keep this process going. 15 times, instead of x, I'm going to go ahead and put 2. 15 times 2 plus 5. So 15 times 2 is 30. 30 plus 5 will be 35. So then that's going to be after 2 hours, she gets the $35. Oops. And if you feel like you need more practice with plugging in these values, please reach out to me. Like if you see this and you're like, what the heck is she doing? Please reach out. I can give you a bunch of practice problems that we can do together. And then finally, I'm going to go ahead and do y equals, sorry, I moved over here, 15. But instead of x, I'm going to put 10. And remember, we just made up these x's. We can pick any value we want for x, as long as it makes sense with our problem. X represented our hours. So 0 hours, 1 hour, 2 hours, 10 hours, those all make sense with the problem. Again, we can't have negative hours. That's why I don't have those negative numbers there. Okay, so let's finish off this one. 15 times 10 is 150. Plus 5 will be 155. So if her boss worked her for 10 hours a day, in just that one day, she's going to go ahead and make $155. Okay? Let's go back to the problem and figure out what they wanted us to do. So Lana makes 15 an hour. She already has 5 in her account. Got it there. Graph the relationship. So they want us to graph these numbers. So I'm going to go ahead and make a graph. Go ahead and take this time to set up your graph on your paper. I'm going to scroll down. Labeling my x and y intercept. And then I remembered that none of these are negative. So that's why I kept these negative sections, these negative quadrants, very small. Because I am only going to be working with mostly the first quadrant. Let's extend this a little bit. Okay, my y and my x. And then I'm going to go ahead and just start, whoops, sorry, I have to create a scale. So my x's, I'm just going to do 1, 2, 4, 5, 6, 7, 8, 9, 10. Okay, and then if I were to go back, it is negative. Oops. These would be -1, but again, I'm not going back because these are my x's. X represents the hours up here. X represents the hours, so I don't want to go backwards because you can't have negative hours. Looking at my y's, 5, 20, 35, 155, I'm probably going to want to count by 5s, maybe 10s. I'm not sure if I'll be able to get this 155 point here. If I don't, it's okay. So if I do 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 20, 30, 40, 50. Ooh, actually I kind of do. I'm going to go ahead and count by 10s. So I have 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, and my y was 155. So I'm going to go ahead and just extend it a little bit. Okay, so if you're not done creating your graph, go ahead and press pause because I'm going to just jump right into it. So we're going to start plotting these points. So the first one is 0, 5. So I'm going to go over 0 on my x-axis, up 5, which will be right there. And again, if you want to, I'm going to go ahead and just move this table here so that way I don't have to keep going back and forth. If you want, you can create points out of these. So remember 0, 5 is technically 0, 5, and 120 is 1, 20, and 10, 1, 10, 155. So you can create points out of all of these here. And these are the points we're going to plot. I'm going to erase these so they're out of my way. But those would be the points you can plot. If you wanted to get them down, just go back, pause it, all that stuff. Okay, so then over 1 up 20 will be right about here. Over 1 up 20. Over 2 up 35. 20, 35 would be right about here. This is 30, this is 40, so 35 right in the middle. 2, 35. And over 10 up 155 is actually going to be way up here. I'm going to go ahead and delete this table now so it's out of my way. Delete. So this final one was over 10 up 155. That would be right about here. Over 10 up 155. So when I connect these should make a straight line, and I'm doing it on the computer, so this is actually going to make a perfect straight line for me. Yeah, perfect. Okay, but remember these are linear equations, so all of these should be the straight line, which basically just means they all follow a pattern, which this pattern in this case is 15 an hour, which is our slope. Remember, the pattern is the slope. Okay, let's go back up to the problem and see what they wanted us to do. So it says she makes 15 an hour, already has 5 in her bank. Graph the relationship between her hours of work and the money in her bank account. So that's what this graph is here. It is X is her hours of work. So this was her hours. So that means all of these numbers here represent her hours of work, which is again why we didn't go negative. Can't have negative hours. These are going to be her, it says Y was her money. So all of these numbers here represent her money. So now the reason we create these graphs is because these basically can let us do predictions. So what I mean by that is I can go over without even plugging in any numbers. I can say, okay, at 6 hours, stop at the 6, how much money is she going to have? Let me go up to the graph. and see where do I land. So this was over 6, and if I go here, this was 90, so that means this must be 95. So just from my graph, I can predict that if she works 6 hours, she's gonna have $95. And I didn't do any math here. I'm gonna do the math just to check it. So remember we had y equals 15x plus 5. If I plug in y equals 15 times 6 plus 5, multiply these, 15 times 6 is 90. 90 plus 5 is 95, which is the math there. Okay? So the reason we're creating these graphs is because it lets you shortcut, basically. It lets you predict, and we could keep going. And if she just keeps working forever and keeps going up and up and up and on her hours, she'll keep making more and more money. Last portion, sorry, I almost forgot. We have to label our x and y intercepts, x-intercept, and your y-intercept. So your x-intercept is where your graph crosses the x-axis. For this particular situation, our graph does not cross the x-axis. Actually, we're gonna hold off on this part. Delete. One other thing we're gonna go ahead and label is we're gonna label our y-intercept. Oops. Oops. Let's get this all out of here. Okay, we're gonna go ahead and label my y-intercept. So your y-intercept is where your graph crosses the y-axis. Your y-axis, remember, is the vertical line, so my graph crosses the y-axis right here at 0, 5. And I would say that the end behavior of this graph, which basically is it decreasing or increasing? It's going to be increasing. And that makes sense with this problem because if she makes 15 an hour and she doesn't spend anything, her value is going to keep going up and up and up. Okay, if you would like another explanation of this, please reach out to me. Otherwise, you guys are going to have a sample problem on your own. What I would like you to do is you're going to do the problem on your own sheet of paper. I would like you to take a picture of it and paste that picture on the slide. If you're having trouble doing that, please